In this video, we're going to talk about how to solve absolute value equations. We'll save inequalities for another video. When we solve an absolute value equation, we want to get rid of the absolute value brackets so we can solve using regular algebraic technique. And there are rules for how to do this. Recall that the absolute value of a number is the distance of that number from zero. So for example, the absolute value of 7 is 7, because if you were to draw a number line, 7 would be 7 units away from 0. The absolute value of negative 7 is also 7, because negative 7 is 7 units away from 0. The absolute value of 0 is 0. Okay? Now, from the previous slide, we can state the following rule. If W is greater than or equal to 0, then the absolute value of W is W. So, for example, let W equal 0. Then the absolute value of 0 is 0. This is true. Similarly, let W equal 7. Then the absolute value of 7 is 7. This is also true. So, it's an important thing for us to remember what's written in red. If W is greater than or equal to 0, the absolute value of W is W. Another important rule is this. This one is a little bit more difficult to see, perhaps. If W is less than 0, then the absolute value of W is negative W. Now, this makes sense if we think about it. For example, if we let W equal negative 7, then we're saying the absolute value of W is equal to negative W. Well, negative of negative 7 is 7. It's like saying it's doubly negative, which in this case would mean it's positive. So it actually works. That negative sign in front of a quantity we know to be negative makes it positive and lines it up with what we know to be true about absolute values. Okay? So let's solve this equation. Absolute value of 5x plus 2 equals 13. Now, we're going to do this equation, we're going to solve this two different ways. The first way is a lot quicker, but it only works in a very narrow set of circumstances. If one side of the equation is an absolute value quantity and the other side is simply a non-negative value, we can simply state that the interior of the absolute value bracket is equal to plus or minus the quantity on the other side of the equal sign. So in other words, here we only have one absolute value quantity on one side and a non-negative quantity on the other side. So what we're going to do is we're going to take the argument of the absolute value and we're going to say that that equals plus or minus 13. Now, again, this only works in a narrow set of circumstances. Okay? And you don't want to be a student who uses this rule when it's not appropriate. We'll talk about those examples shortly. So, in this example, we can use this little shortcut method. We know 5x plus 2 is plus or minus 13. So if 5x plus 2 is negative 13, then that means x is 3. Negative 3, sorry. And if 5x plus 2 is positive 13, that means x is equal to 11 over 5. And both of those are valid answers to the question. Okay? Now, you might say, how can that be? Well, if we do 5 times negative 3 plus 2, that would equal the absolute value of negative 15 plus 2, which is the absolute value of negative 13, which is 13. And then if we plug in 11/5 for x, we would get the absolute value of 11 plus 2, which would ultimately equal 13. Okay, so they're both valid answers. Now, there is an alternative method which involves making intervals and using the two rules mentioned earlier. Those two rules are going to be key no matter what method we use. If W is greater than or equal to 0, then the absolute value of W is W. If W is less than 0, then the absolute value of W is negative W. Now, for method 2, it's not necessary for this question, but I like to show it for this type of question so that you see it in the more complicated questions. What we're going to do is we're going to let the interior of this absolute value quantity equal to 0. We call this the argument. We're going to let 5x plus 2 equal 0 and then solve for x. X ends up being negative 2/5. So we're going to construct a number line with a -2/5, and we're going to build a wall there. Okay, this vertical wall, whoops, right there. Now, in order to solve this equation, we want to get rid of those vertical absolute value brackets. So in order to do that, we have to remember those rules that we've been repeating numerous times. To the left of x equals -2/5, we know that 5x plus 2 is less than 0. Pick any number to the left of -2/5, say for instance -1. 5x plus 2 would be a negative number, no matter what number we pick. So that means since 5x plus 2 is negative, the absolute value of 5x plus 2 is negative of 5x plus 2. Remember we said earlier, if w is negative, the absolute value of w is negative w. So if 5x plus 2 is negative, the absolute value of 5x plus 2 is negative quantity 5x plus 2. So to the left of x equals -2/5, what we're really trying to solve is this equation right here. Because to the left of -2/5, the equation we were given is the exact same as this other equation, negative regular bracket 5x plus 2 equals 13. See, we wanted to get rid of those absolute value brackets so we could solve. Now we're rid of them. Now we just use our rules of distribution and solving that we're aware of from earlier grades, and we say x is equal to -3. Now, there's one more thing we have to check. We just got the answer x is equal to -3, but the interval that we're in to the left of -2/5, that x less than -2/5 is like a restriction. Well, it is a restriction. So any answer emanating from this interval must meet the condition that x is less than -2/5. In other words, the answer x equals -3 is only a valid solution if -3 is in this interval, i.e. to the left of -2/5 on a number line. Well, -3 is in this interval. So therefore, x equals -3 is a valid solution. See, -3 is right here. It is to the left of this wall that we built. So that means this -3 will be a valid solution. Okay. Now let's go to the right of x equals -2/5. Well, to the right, we know that 5x plus 2 will be greater than 0. Let x be any number you want to the right of -2/5. Let's say 0. Well, 5 times 0 plus 2 is equal to 2, greater than 0. True of any number that we choose to the right of -2/5. So that means the rule we stated earlier, if w is greater than 0, then the absolute value of w equals w. Well, since 5x plus 2 is greater than 0, that means the absolute value of 5x plus 2 is 5x plus 2. So in other words, to the right of x equals -2/5, we're not solving this complicated equation. We're solving this simple equation. Isn't that nice? So 5x plus 2 equals 13, which means x equals 11/5. But don't forget, x greater than -2/5 is a restriction for this part. So any answer emanating from this part of the interval must meet that condition. So x equals 11/5 will only be valid if 11/5 is to the right of -2/5 on a number line. Well, 11/5 is out here somewhere, so that means 11/5 will be a valid solution. So now we've tested each interval. We have our valid answer. X equals -3 or 11/5. Now, to repeat, for this type of question, where there's only an absolute value quantity on one side and the other side is simply a non-negative value, you don't have to do method 2 with the interval testing. You can do the quicker method we described earlier. But it only works in a narrow set of circumstances. That quicker method, we're going to do a couple questions now where we have to use the interval testing method. So here's a next example. The absolute value of 2x plus 9 minus the absolute value of x minus 4 is equal to 5. Now, we can't use that quick method here. It doesn't work because there are two absolute value quantities on the left side. We must use the interval method. The last question we did, there was only one absolute value interval on the left-hand side. That's why we were able to use that quick method. But this one here, This has two of those absolute value quantities on the left side. We can't use that quick method. So let's build some intervals. We're going to set the interior of each absolute value bracket equal to 0 and solve for x. Well, if we set the first one equal to 0, we get x equals -9/2. We set the second one equal to 0, we get x equals 4. We're going to build a number line, and we're going to mark off both x equals -9/2 and x equals 4. So we've marked off two different values. Now what's happened here is we've created three intervals. Let's go into interval 1. In interval 1, x is less than -9/2. So think of a number less than -9/2, perhaps -5. Well, if we think of -5, then the interior of the first absolute value bracket is negative, and the interior of the second absolute value bracket is negative. So they're both negative, which means 2x plus 9 is less than 0, and x minus 4 is less than 0. Now remember that rule that said if w is negative, the absolute value of w is negative w. Well, if 2x plus 9 is negative, then the absolute value of 2x plus 9 is negative of 2x plus 9. And if x minus 4 is negative, then the absolute value of x minus 4 is negative of x minus 4. That allows us now to get rid of both of these weird-looking absolute value vertical brackets and just put regular brackets right here that we know how to deal with. We know how to do these round questions with these round brackets. So we plug in negative round bracket 2x plus 9 round bracket for absolute value of 2x plus 9, and we plug in negative round bracket x minus 4 round bracket for the absolute value of x minus 4. And now we solve, and we get x equals -18. Now remember, that's only valid if x equals -18 is in the interval x less than -9/2. So is x equals -18 out here somewhere? The answer is yes. So that's a valid solution. Let's look at the middle interval. Now, when we're in between -9/2 and 4, we have to know whether 2x plus 9 or x minus 4 are positive or negative. Let's think of a number in between -9/2 and 4. Let's think of the number 0. 0 will work. Now, 2 times 0 plus 9, is that positive or negative? Well, that's positive. So that means 2x plus 9 is greater than 0, which means the absolute value of 2x plus 9 will be 2x plus 9. Sweet. Now, let's think of a number, that same number that's in between -9/2 and 4, which we said is 0. That's the number we're testing. We could pick any number we want. Well, if we evaluate 0 minus 4, is that going to be positive or negative? The answer is that's negative. X minus 4 is less than 0. That means the absolute value of x minus 4 is negative of x minus 4. Now, we take this original equation and we rewrite it, subbing in what we said each of those absolute value quantities is equal to. Now we solve. And we actually get x equals 0. It's a coincidence that we got the number we were using as our tester is actually the solution. That's just a coincidence. Now we ask ourselves, is 0 in this interval? Is 0 somewhere between -9/2 and 4? It is. So that means it's going to be a valid solution. Awesome. Last one. Now, when x is greater than 4, pick any number you want greater than 4. Let's say 100. Okay, well, if I let x be 100, then 2x plus 9 is positive. And that would mean 2x plus 9 is greater than 0, so the absolute value of 2x plus 9 is 2x plus 9. If I let x be 100, then 100 minus 4 is also positive, which would mean x minus 4 is always positive in that interval. And so I can say the absolute value of x minus 4 is x minus 4. Now I can take this original and I can solve it, plugging in the quantities for the absolute values that we just underlined directly above. And when we do that and solve, we get x equals -8. Well, remember, this is only valid if x equals -8 is in this interval. But this interval is all numbers to the right of 4. x equals -8 does not meet that restriction. So x equals -8 is not a valid solution. So we're not going to include that. And so we only have two different answers, x equals -18 and x equals 0. And there we go. That's our final answer. And we'll do another one here. Solve for x, where x minus 2 plus absolute value of x minus 2 plus absolute value of 5 minus x equals 6. Now, again, as mentioned before, we don't only have one absolute value quantity on the left and a non-zero quantity on the right. Because that's not the simplicity of our situation, we have to build intervals. We can't simply state that shortcut method where what we're given is equal to plus or minus 6. Now, another warning is the coefficient of x in the second absolute value bracket is negative, and sometimes that throws people off. You might see what I mean when we do the question. So let's set the interior of each bracket equal to 0 and solve for x. Well, if I let the argument of the first absolute value quantity equals 0, I get x equals 2. And if I let the interior of the second one equal 0, I get x equals 5. So we're going to build number line with two values marked off, 3 intervals. Now, when x is less than 2, let's say x is a number like 1. 1 minus 2 is negative. So that means x minus 2 is less than 0. So the absolute value of x minus 2 is negative round bracket x minus 2. But if I let, again, we let x equal 1 here as our testing to the left of 2. So using 1 as our tester, again, 5 minus 1 would be positive. So that means in this interval that 5 minus x is greater than 0, which means the absolute value of 5 minus x is 5 minus x. So now what we want to do is solve this equation, but plugging in, substituting in what we just said we could. Negative round bracket x minus 2 plus 5 minus x equals 6 simplifies to x equals 1/2. Now we ask ourselves, is that in this interval? Well, it is. X equals 1/2 is a number to the left of 2. So we're going to include that in our final answer. And you may have guessed by now what we're doing with that number line up top is we're using it to organize our final solution. That'll really become a useful thing when we get into inequalities. It's extremely helpful there. Now, let's look inside this interval here. Let's let x be a number between 2 and 5. For instance, let's let x be 3. Well, 3 minus 2 is positive. So that means the absolute value of x minus 2 will be x minus 2. And 5 minus 3 is positive. Again, we're letting x be 3 just for a moment to test whether these arguments of the absolute value are positive or negative. And when we let x equal 3, the absolute value of, we see that the absolute value of 5 minus x is 5 minus x. So we can actually just solve x minus 2 plus 5 minus x equals 6. Now, when we do that, believe it or not, the x's cancel out, and we end up with 3 equals 6. Okay, this is an impossibility. There's no x's at all. 3 equals 6. What that means is there are no valid answers anywhere in here. If you do the correct math steps to solve and you get something as ridiculous as 3 equals 6, that means that there's no valid solutions at all within your interval. Now, finally, let's look to the right of 5. We'll let x be a number to the right of 5, let's say 10. Well, 10 minus 2 is positive, so that means x minus 2 is greater than 0, which means the absolute value of x minus 2 is x minus 2. Now, again, letting x be 10 just for testing purposes, 5 minus 10 is negative. That means the absolute value of 5 minus x is equal to negative of 5 minus x. Now, we sub those, instead of solving this equation, we're going to solve this equation. We get x minus 2 minus 5 plus x equals 6, and we get x equals 13 over 2. Now, is 13 over 2 to the right of 5? It sure is. And since it is, we're going to include that answer in our solution. And we get our final answer that x could be 1/2 or 13/2. And that is the end of this presentation. We're going to solve everything you're looking at here with the inequalities for a future lesson. And that future lesson, when we do those inequalities, you'll see the importance of having a good number line.